Hello and welcome to this lesson number 4 about the basics of computing. During this lesson we are going to further study the imaginary computer that we started in a previous video, and this time we will do some programming by using the machine instructions, and we are also going to study what is a jump in a computer program. And in the end we are going to create an infinite loop or endless loop. Those things are quite bad things in computer programs, but well, maybe it's a little bit fun to do such a thing during this lesson. So let's open the imaginary computer. So you can find it through naturalprogramming.com, and through this IC8 icon you will end up to this page, and through this link you can find this actual imaginary computer, or actually this is a simulator for the imaginary computer. And so last time we studied some instructions with which we can load some value to this register A, and then we can output that value to the screen, and the screen works so, or the output port works so that always when the value is written to this output port, then the corresponding character appears on the screen. But let's this time do some programming. We will not use any installed program or a program that exists inside the simulator, but we are going to create the program ourselves. And you probably remember that there were these were the instructions that we were using in the previous video. So the instruction 1.5 means that the value is loaded to register A, and instruction 9.2 means that the content of register A is output to the output port, and the character is printed or appears on the screen. So by using, let's decide that our task is now to create a program that prints the letters X, Y, and Z to the screen. So if you can find this character code table through this More button and through this codes icon here, and I have it already open here. So I have these character codes available, and we can see that the character code of letter X is 5.8, the character code of letter Y is 5.9, and the character code of letter Z is 5.8. So we can, if we want to print the letters X, Y, and Z to the screen, we must first load, or we can do it so that we first load these character codes to the register A, and then we use the 9.2 instruction to output the character. So let's do that. So it is 5.8 is the instruction for, or the character code for uppercase X. So I have to when I use this modify button, I can actually write or create the program to the memory, to the main memory of this computer. So I press the modify button, and then when I click a memory location here, I can write something there. So I will first put the 1.5, which means is the machine instruction code, and then the following byte is the operand. And now I put 58 there, because that is the character code of letter X. And actually, you also might remember that the instruction B2 was the instruction that terminates a program. So if I press this modify button again, I get away from the modifications state of the simulator. And actually, there seems to be a problem with this simulator. So there is some error here. If I try to press this continue button, nothing happens. So I can't execute the program which I wrote or put to the main memory. So first I have to press this reset button, and then I'm able to execute the program. So now it should print only the letter X. Now it first fetches the instruction code, and it sees that the code is odd, so it fetches the operand as well, and it copies it to the operand register, and now it executes, and it copies the operand value to register A, and now the instruction is executed. And now it fetches the next instruction, and that is the instruction B2. And processor stops. So actually I made a mistake here. I'm sorry. I forgot to put the 9.2 instruction to the main memory. So I have to modify the program and put the 9.2 instruction there, and then I put the B2 instruction there. Now it should work. So I can reset the processor and I execute. So now it should print the letter X to the screen. Now it's fetching the operand, and it copies it to the operand register, and then it copies the operand register to register A. And now it fetches the next instruction, which is the 9.2. And it's an even instruction, so it doesn't need the operand. And now it copies the value from register A to the output port, and it automatically the corresponding letter appears on the screen. So, this printed the letter X to the screen, but when we want the idea was that we would print the letters X, Y, and Z. So we can do some tricks here, because you can see that there is X, Y, and Z, so they are the character code of Y is one larger than the character code of X, and then the character code of Z is again one larger than the character code of Y. So we can do some mathematics here. So I have here open the document or the one chapter of my Java book that lists all the instructions of this imaginary processor. It says that this is instruction decoding table. So you can think that this imaginary processor has this kind of table inside it, and then it always checks that well, if there is the load register A with value, then it does these things that are explained here. But what we can see here is that there is this kind of instruction increment register A. The content of register A will be incremented by 1. For example, if the content of register A is 34 hexadecimal, its content will be 35 hexadecimal after the execution of this instruction. Because we now know that the character codes or we can do some mathematics to get the character code of y from the character code x if we use this instruction. So we can modify this program so that we will put there this 16 instruction, which is the increment. So I will write it here. So 16 means increment register A. So also let's put it here, this B2 means stop processor. This was the instruction that doesn't exist in real processors. So with that, when we use that instruction, we can actually very easily print the character codes, so that we can when I add this 9.2 instruction here, and I again add this 1.6 instruction here, and I add this 9.2 instruction, and I terminate the program with a B2 instruction. So with these modifications, so what it does here, it first loads the value 58 to the register A and outputs it, then it adds 1 to this register A, and then it outputs that value, and then it adds 1 to the register A, and then it adds it again. So this way we should be able to, or we will be able to print the letters X, Y, and Z. Let's reset the processor first and then execute. So it starts from the beginning. It's fetching the operand for the instruction 1.5. Now it's fetching the next instruction code. Now it executes the first, or the 9.2 instruction, and goes on to fetch the next instruction. It's 1.6, it's not odd, so it will be executed immediately. And now the value of register A will be 5, 9. And again it fetches this instruction 9.2 and it outputs the letter Y to the screen. And it goes on to take the next instruction. Now it's fetching the last 9.2 instruction. And now it did output the value Z. And now the processor is stopped. So again, here we can say that this computer program is now that the variable thing that we created here is this computer program, and the actual computer program is now this sequence of numbers 1 5 5 8 9 2 9 2 1 6 9 2 1 6 9 2 and B2 is the last instruction. So this is a program to print. So this is the program to print so this is not very clever program, but in any way this is the way I can show you what is actually the computer program. So basically you could do so that you would just write this program, or theoretically you could do so that you would write this computer program and tell your friend that, well, I have this fine program that can print the letters X, Y, Z with an imaginary computer, and here it is. And so you could try to sell it to your friend or some other customer. Of course, the selling would be difficult, but that's basically what's happening in the world of computers. That companies are making programs, and well, many companies are selling the programs, and they adjust some sequences of machine instructions for some processor. Or in many cases they are like this, but of course they are very much larger programs than this, and they can contain millions or thousands of millions of bytes. But this is the principle of computer program. It is a sequence of numbers in its executable form. And we also saw here that it is possible to do programming with these numbers, but it is quite difficult. And later on we will learn how to do programming in a different way. Okay, but so we have this program, but let's still modify it a little bit, and we will create this endless loop which I promised. So there is this instruction, I remember the code. There's one instruction for 1 and that means jump to address. So this instruction requires an operand, and the operand is an address where the program, from where the next instruction should be fetched. And now it is very important to understand that how this program pointer works. So this program pointer always contains the address from where the next instruction will be fetched. And again here, it always when the current instruction is read or fetched from the memory, this is incremented so that it points to the next instruction, and it is usually the next memory location. And in this case, when this program terminated and this instruction B2 was fetched from the memory, it was incremented to value 08, which would be this address, but because the processor stopped, that instruction was never read from the memory. But there are but this jump instruction is such that with that we can modify this program pointer. So if I again modify this program, I will write here in place of this B2 instruction, I will write this 41, and it needs an address, so I will put there 00. And then I can put this B2 here as an end of the program, but that will be never reached. But let's see how this works now. So I reset the processor and I execute it. So it starts from the beginning. It does the same things as we actually saw, and so it prints the letters X, Y, and Z. So there is also a feature in this IC8 simulator that you can go quickly to certain memory locations. So if I would like to these first instructions to be executed very quickly, I can press one memory location, and then it goes with full speed there, and then starts then with a slower speed. So I will click this instruction in address 06, so it will go in full speed there. And now it goes slow with a slower speed. And then we can see how this jump instruction works. Now it has printed the X, Y, and Z, and now it reads the jump instruction code 41, and it sees that it's odd, so it fetches an operand, and so you can see that now the operand has been fetched, and the whole instruction is fetched. And now this program pointer points to, or contains the address 09, which means the next instruction after this current instruction. So that would be normally the address from where the next instruction would be fetched. But let's see what happens. So now this instruction jump to address, it wrote this value that was given as an operand, it wrote that value to the program pointer register. And that means that the next instruction will be fetched from the address 00, which in practice means that it will fetch the first instruction of the program. or we can think that the program execution or the program control now jumps to the beginning of the program. So now it takes the first instruction there and it will start executing these instructions so that which were already executed once. So the same letters will be printed to the screen. So I will increase the speed a little bit. Always when it reaches the instruction 4.1, it will then modify the program pointer register, and it means that it will go to the beginning of the program. And if I put it to the full speed, you can see that it prints these letters X, Y, and Z, X, Y, and Z forever. So now we say that we have a, so you can see also here that it is repeating the same instructions over and over, and it prints the same characters over and over, and it never stops. Or well, someday it will stop, but when this computer would break. But this is now called an infinite loop or endless loop. And these are called loops when the same instructions are executed over and over. They are called loops. So, and let's pause this now. And I could still make some modification there. We could make a funny or a little bit funny modification, because we can see that or we can generate a little bit different output when we make so that because now it is jumping to the beginning of the program. But if we modify this instruction so that it doesn't jump to the beginning of the program but to the instruction 1.6, that increments the register A. Then we should get a different kind of endless loop that will print different characters to the screen. So let's modify it again. I modify only the operand of this 4.1 instruction, and I put this address 03 there, like this. So now I modified it and I reset the processor, and again I execute the thing. And I will put the, let's go with full speed to the 4.1 instruction. Now we are in the 4.1 instruction, the jump instruction. Now it reached its code, and then it reached the operand 03 or 03. And now it copies the operand value to program pointer, which means that we will jump to, or the next instruction will be fetched from address 03. now it increments the register A, and we get a totally new value there. So it is 5B. Is 5B, and that is the code of opening bracket. So now it goes this way, and if we put it full speed, it should repeat these instructions which increment the register A, and it should print more and more exciting characters to the screen. Now it's always incrementing the register A, and it prints all the values that can be seen in the character code table. So there is also a possibility that it seems that it doesn't print much. It seems that it doesn't print if the character codes are bigger than 7F. It doesn't print anything there, or they are not visible on the screen. But then it starts. Oh, it prints some strange characters there. I'm sorry, I can't fully explain why it prints that kind of characters, but but eventually the register A, because you can see now that the register A has this value BA, BC, BD, BE, so it goes through all these values, and eventually after the register A has reached the value FF, I think it will go back to 0, and a little bit later it will start again printing some more meaningful characters there. So but this is we only modified 1 byte in this program when we could make this modification, so that here you will see also that we can with very small modifications we can really make big things happen in a program. So you saw that this is incrementing the register A, and so now it is after FF it went back to 0, and it should soon start print these characters like exclamation mark and dollar sign and percent sign and numbers, and it should print those quite soon. Yes, so soon we should get, so now soon it should start printing numbers, because 30 is the code of 0, 31 is 1, and like this. And 41 is the code of uppercase letter A, so soon it should print the uppercase letter A. So now it starts printing the normal alphabet. So it will continue this forever now. So this is endless loop. So in next video we are going to study non-endless loops, so that we will be using more of these jump instructions, and I will show you that it's really possible to do also useful loops. So all loops don't need to be endless. So I thank you for watching this video, and we'll meet in the following video.